Welcome to this episode of Frequency Matters, the RF and Microwave Update Series. I'm Pat Hindle, and I'm talking with Joel Levine, President and CEO of RFMW. Welcome back to the show, Joel.
Great to be here, Pat. Thanks for having me again.
Yeah, I think you may be setting a record for the most appearances.
I hope that's a record I want to set.
So RFMW recently announced new branding and expansion into the power market, which sounds exciting. Why did RFMW expand into power?
And as you know, power management is needed everywhere. It's truly a complementary product to provide to our customer base for their power requirements. Adding power components to the RFMW portfolio creates additional opportunities for new business at existing accounts and also opens the door to address new applications and markets for RFMW outside of RF. Our goal and our strategy is to duplicate and power the successful specialist strategy that we've developed and deployed to the RF and microwave market. That's been successful for us in RF and microwave, and we think we could duplicate that again in power.
So why is DC power important to RF?
Again, as you know, active RF circuitry can't function without DC power. Furthermore, a given system will likely require multiple voltage rails to supply power to the wide array of devices within the system. AC to DC and DC to DC converters such as buck boost and LDOs are used in the system to supply the specific voltage and current levels needed for each rail.
So are there any special considerations for DC power for RF?
The type of power supply or converter chosen should be based on the specific individual design requirements and sensitivity. In an RF system, there are likely many different devices that need to be powered, and some are more sensitive to power supply noise than others. In general, these devices include, but aren't limited to, oscillators, LNAs, transceivers, mixers, and ADCs. A frequent issue is noise or ripple on the power rails, coupling internally to the device that can lead to added phase noise that degrades performance and increases complexity in filtering. Proper design techniques must be used to maintain overall power integrity and ensure proper function system-wide. That's why we want to be specialists within power management to make sure we can provide the right components for the customers for their systems.
Yeah, it makes perfect sense. What DC power products are available today and are suited for the RF applications?
Well, a great example of devices would be Qorvo's ACT 41000, ACT 43750, and ACT 43850. These are used to power GaN and GaAs RFPAs. In addition to clean power, these products include proper turn-on and turn-off bias sequencing to the drain and the gate of the PA on the GaN device. Additional functions include auto-tuning at every power-up to compensate for temperature fluctuations and aging to optimize performance.
How about power beyond RF? Are you addressing other markets with these products?
Yes, although RF is our first target, we're addressing power conversion and power management applications because it's important across all applications. RFMW currently offers highly efficient and compact semiconductor solutions ranging from less than 50 watts to hundreds of kilowatts. Lower power products include modular PMICs, power loss protection, DC to DCs, and battery monitoring products for small battery powered devices. Applications included are for power for portable and audio and video, solid-state drives, computer vision, IoT, POS terminals, cameras, and video doorbells, to just name a few that we're going after. In higher power applications, greater than 1 kilowatt, wide bandgap semiconductors like silicon carbide and GaN are leading the charge to achieve greater efficiency and improve performance. We currently offer silicon carbide FETs, JFETs, and Schottky barrier diodes from 650 volts to 1700 volts, available in through-hole and surface mount packages. Most are AEC Q101 qualified. Applications include EV chargers, traction inverters, photovoltaic inverters, industrial battery chargers and power supplies, motor drives, induction heating, telecom and server power supplies, for instance. Example, data centers, which are going up all around San Jose from where I'm sitting right now, consume hundreds of billions of kilowatt hours of energy per year globally. Using wide bandgap semis and server power supplies greatly improves efficiency while lowering power consumption and cost. To go along with the fast-switching high-power silicon carbide devices, RFMW offers multi-layer capacitors and assemblies from Knowles NovaCap. Knowles multi-layer capacitor assemblies use vertical stacking of ceramic capacitors to reduce the overall circuit board footprint. These devices offer low ESR and ESL values, giving the assemblies the ability to hire high ripple currents and high frequencies, making them ideally suited for the input and output stages of switch mode power supplies, DC to DC converters, high capacitance discharge units, and high temperature filtering and decoupling. RFMW is also building our power line card to include additional passive and thermal management products, including film and electrolytic capacitors, resistors, and magnetics. Our recent acquisition of GigaComp MRC components in Germany adds a wide selection of magnetic cores and common mode chokes to the RFMW power lineup. We'll also be looking at thermal management solutions that will include air and liquid-cooled options. So to sum it up, Pat, RFMW is deploying the specialist strategy that was successful for us in RF microwave, and it's all about creating a team of knowledgeable specialists and a line card of products that provide power solutions for our customers' requirements and power. It's all about people and product, and that's the RFMW strategy in RF and microwave and now in power management.
Wow, that's a lot of applications, and you certainly bring a lot of products to the party. So I think it's a good way to expand. Well, thanks, Joel, for talking with me today about RFMW's expansion into the power market. It's a critical area for both RF and digital circuits, so it will be interesting to follow you as you expand in progress. To our audience, you can find more videos at videos.microwavejournal.com. Thanks for watching.